Hey you guys, in this section we're going to be talking about exponential growth and decay models. Okay, so the first thing that we're going to look at, it says that many natural phenomena have been found to follow the law that an amount A varies with time t according to the function a of t equals a subscript 0 e to the kt, where a subscript 0 is the original amount when time equals 0, and k does not equal 0 is a constant. Okay, so as we begin to look at exponential growth and decay models, this is one of the base formulas that we're going to be using. Okay, so in this formula, okay, a naught or a subscript 0 always stands for your initial or your original amount, okay, or the amount that you start with. Okay, k is going to be your growth factor. It lets you know either how fast something is growing or how fast something is decaying. And t is always going to be representative of time. Okay, so when we use this model, that's what those variables stand for. And we know that e is a number. Okay, so these are exponential models because this is an exponential function. Okay, remember you can tell it's an exponential function because your variable is in the exponent. Okay, all right. Now, depending on what k is, okay, so the model that we use is going to be identical for if we're solving for growth or if we're solving for decay. The only thing that's going to be different is if what k is. So if you look at your model, okay, there will sometimes be a number here where k is, okay? If k is greater than 0, that means that your amount A is increasing over time, which lets you know you have a growth model. It means whatever your quantity is, it's growing as time increases, okay? Now, if you look at your model and k is less than 0, it means that your amount of whatever you're dealing with, it's decreasing over time. So this would be a decay model, okay? So sometimes in either case, when an amount A varies over time, according to equation 1, which is this, okay, it is said to follow the exponential law or the law of uninhibited growth, okay, or decay. So uninhibited, okay, if you guys have never heard that before, uninhibited means without borders, without boundaries. It just continues on without anything stopping it. So one thing about these models, we use them a lot to either explain how something is growing or something is decaying. Now, in these mathematical models, keep in mind that these are not in real world scenarios, okay? So let's say, for example, I have a pond and I throw some fish into the pond and I want to model how fast the fish will grow in the pond. Well, we know that the fish can't grow on forever. Eventually, they're going to run out of food, they're going to run out of space. But these models allow us to model something over a period of time. And then I need to take into account the natural barriers or obstacles that would stop that from happening. Okay? So either way you go, you're going to use the same formula, but just pay attention to k, because depending if k is negative or positive, will tell you if you're dealing with a growth or a decay model. Okay? Now the cool thing is, these display certain properties on a graph. So a growth model, like the picture on the left, because it's growing, that graph is increasing. So remember, if you're reading your graphs from left to right and you think about them like roller coasters, a growth model is going to be rising from left to right. Okay, so any growth model problem you have will be increasing. And the graph on the right side, that would be an example of a decay model. Okay, so if you think about your graph like a roller coaster, as you move from left to right, this graph is decreasing, okay, which shows that something is decaying.